The melting point of a synthesized compound is characteristic of the compound. Not only can it determine its identity, but it can also assess its purity when compared to the literature melting point, which is the assessed melting point of the purest version of that compound. But it isn't always just the measure of a single temperature. It can actually be defined as a range of temperature points that describe the process of a compound melting. The way we determine the melting point is using a melting point apparatus, and in this video I'll show you how to use it. This apparatus has 3 different chambers that each fit 1 capillary tube, which I have in my hands here. And since I have 3 products, I'll have 3 capillary tubes with each of my products inside. One will have p-bromoaniline, one will have naphthalene, and the third will have benzoic acid. To get your solid product in the capillary tube, simply take your tube, flip it upside down, and place it inside your beaker or flask, and simply tap a few times to get the product inside the tube. Then, take it out, flip it over again, and tap it on your bench until the product falls to the bottom of your tube. Once it's in the bottom of your tube, you can place it in one of 3 chambers. While I add the other 2 compounds into their tubes, I'll explain the melting point range. The first melting point temperature is when the compound inside of the tube first begins to melt, and the second temperature is when the compound is completely melted. From left to right, these tubes contain benzoic acid, naphthalene, and p-bromoaniline. These happen to be known compounds, and according to the literature, the melting points of these pure compounds are respectively 122 degrees Celsius, 80 degrees Celsius, and 66 degrees Celsius. So if my compounds that I have synthesized are decently close to being pure, then the solid products I have will melt in a narrow temperature range in order from lowest to highest temperature. Now what we can do is turn on the apparatus using this switch. I've turned the knob to about 15 degrees above the highest melting point. That way, as the temperature inside the apparatus increases, the solids in the tube will melt accordingly. The actual crude melting point range will not be exact and will range above or below the pure melting point depending on how impure the product is. Here's a close-up of the thermometer. The black bar inside of it will rise, and you need to watch it closely to see what your melting point range is. It's easier to record the melting point range with a digital apparatus, but this will work fine. Now that everything is set up, all we have to do is wait. I didn't get footage of p-bromoaniline melting, but here's footage of naphthalene and benzoic acid melting. You'll see when the compound first starts melting. You have to watch it very closely and then quickly record the first temperature in the range. Once it's done melting entirely, you can then record the second temperature in the range and have a fully recorded melting point range. Once you're done using the melting point apparatus, turn off the machine and take the tubes out. Throw these capillary tubes away in the glass waste container. Thanks for watching, and I'll see you in the next video.